Now we're going to talk about API rate limiting and security. The key thing is that the Google API and the Google data is super valuable. And you could build a website that did nothing but sort of like asked the person for something and then showed them that place and make it be a map searcher. And you added so little value and Google did all the hard work. And so they protect these somewhat. Sometimes they'll say you can only do 50 of these a day or 500 a day or whatever. That's called rate limiting. And sometimes they say you've got to log in, you've got to create an account and get a key with us and then present your keys. So that means that your account only gets so many. And they keep track of who's using their service and how much they're using it. Google gives you even sort of a dashboard that tells you some of this stuff. It's kind of nice. And so the other thing is sometimes an API is free and then it becomes popular and they decide they're going to put a key on it or a rate limit on it. So you got to kind of play this game with them and the rules kind of change as things progress. So that geocoding API that we're talking about has at one point in time 2,500 requests a day. You can get more requests if you get a key. Now, another API that we can talk about is the Twitter API. Now, Twitter API started out as a free public API, but then Twitter realized that people were making more money off of Twitter's data than Twitter was making off of Twitter's data. And so Twitter makes it so that you have to have an account. You can only request data from their API is if you use your account key to sign that. And so there's a whole series of getting and issuing keys and then using those keys. And I'll just give you a short summary of the kind of code that it takes to build those requests up that have to be signed. So you'll look through the Twitter documentation and it'll say, oh, this URL to get the tweets, etc., etc. And it says do a GET request to this URL and that URL and maybe substitute a little bit of things here for the screen name you're looking for or how many tweets you want. And they tell you how to carefully construct these URLs. And so here's an example bit of code that talks to the Twitter. Now, for now, I'll ignore the security bit. That's all hidden in this TW URL. So it looks a lot like the last one. We're going to use JSON and URL lib. And we have found that this is the API name, blah, 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 list.json, getting a friend list for a particular person. And so that is the base URL that we're going to do. We're going to ask a person for a Twitter account. If we hit enter, we're going to break out. And TWURL augment, we're going to say, give me the first 5 friends of this particular screen name, the one we just read in from input. And this TWURL, you'll see in a second, it adds a bunch of stuff to prove that you are who you are. It's signing that URL. So you're sending a signed URL, which is nothing more than a whole bunch of crazy characters. We'll see that in a second. We retrieve it, and this is pretty straightforward. We can just open the URL, read it and decode it. Decode solves the UTF-8 thing, makes it all so that data is a real string and it's in Unicode internally. Now we can actually get the headers. Remember I told you earlier that URL open bypasses the headers, but it's stored them for later. And we can say, hey, give me back those headers. And that gives us back a dictionary of headers. And the headers, if you go all the way back, are a bunch of key value pairs. Key : value in the headers. And in Twitter, if you read the documentation, there's this x-rate limit remaining that tells you each time it returns to the API, response to the API call that you made, it says, look, you've got 12 left, you've got 11 left, you've got 10. So you can print that out. So this prints out how many you've got left. Then we parse the JSON data. We're going to print it so we can debug it. This dump to string and then printed. Indent equals 4. This is called pretty printing. And it's indenting things really nicely so that you can make more sense of it. Whereas when these things are when programs are talking to each other, they don't really make the output look particularly pretty. And then if we're going to go through, we have the outer thing of users, and we're going to print out the screen name and go grab for each user and users, we're going to print their screen name, we're going to grab their status text and print that out. And so this is what that data looks like. Kind of chopped a bit. So the thing we get is an outer layer, we get users, and then we get a list. And here's the first user. Now if you look at the actual data, it's much larger than this. Here's a second user, and then we have status text, and the screen name. right? And so those are the bits that we're extracting from that. If you look, we are going to grab the screen name, we're going to grab the status text, and away you go. So you can start with this, but you realize that once you're looking at this and you're printing this out with pretty printing, you can sort of work your way in, knowing that it's either a dictionary or a list. If it's a dictionary, you look up the key. If it's a list, you say which position it is, and then you get more dictionaries within dictionaries within dictionaries, and away you go. And so this code actually, when it runs, it prints out the screen name and then that status and the next person. So it's my first 5, in that case, my first 5 friends and their most recent status, the first 5 people. Now, let's talk a little bit about how this security works. And so you have to go to the website. You have to have a Twitter account. You can't talk to Twitter API without a Twitter account. And then you go to this website and then you set up a key. You say, I'm going to build an application that is going to consume the Twitter API. And then you go in, you have to work through, there's documentation on how all this stuff works. You set up an API key, you set the application. So I made a key called Python on my laptop. And it gives us some values. It gives us a consumer key, a consumer secret, a token key, and a token secret. And you get to regenerate these. And there's this file called hidden.py, and you edit them and copy and paste all the stuff from those pages, those 4 values, into these strings. Now, if you download my code, I don't have my keys in there. I got some placeholders for this stuff. So you got to get to this web page that's on Twitter, copy these things in, and then the TWURL code will start to work. It uses a technology called OAuth, which is a way to sign a URL in a way that proves that you have the key and the secret and the tokens, but and it can't be modified in the middle. So once you send this URL, they can check the key and the secret to make sure that you truly signed it without actually sending the key and the secret. It's actually kind of cool and fascinating, but we won't go into it in great detail here. And so if you look at the code in twurl.py, this is the code that does it. It actually pulls in an OAuth library. That hidden.py, that is that code that you've got. And it's got the consumer key, the consumer secrets. This is pulling that from hidden.py. This is a lot of stuff that's using this OAuth library. Don't worry too much about that. Eventually it produces a URL that looks like this. And what happens is this was the base URL you were told to use. Then you have count equals 2 and screen name equals Dr. Chuck. Those parts are your parameters to that web service call. And then all this OAuth stuff is produced by this OAuth code and the consumer key and the secret. What happens is the key gets sent, and the secret does not get sent, but they send this signature, which is based on the secret. And then what it does is it rechecks the signature on the far end. Signature is a long string. By regenerating the signature, because the secret's available to both you to generate the signature and to them to check the signature. So it's kind of like a hash, etc., etc. You don't have to worry about all this. These URLs get really long, and your values that you need are in, the name of the URL is in, and you call this routine. That's called augment. It takes a URL and then parameters and then augments it by adding all this OAuth stuff. And so that's why it's called augment, to augment the URL. And once you got this set up and hidden working, then you sort of just augment the URL and then hit it. Now, if you don't have the right keys or secrets, or you don't have an account on Twitter, then it's going to blow up. But if you get it set up, you will be able to talk to the Twitter API with this. So this whole web services section, we've done quite a bit of stuff, right? We've looked at how instead of reading HTML or flat text, we are creating structured data according to contracts, whether it be XML or JSON. We can retrieve and parse that information in a deterministic way. We talked about schemas that define the contracts so that you know if the data you're getting is wrong, you can know who to blame because the schema gets violated. And we've played with APIs where you're talking to someone else who's defining what the rules are and how to read their documentation. And even if they have an API key or need signed URLs, showed a little bit about how to do that.